Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BBD, ITM, Lucknow. Today we will discuss lecture number 27 and 28 for transportation engineering. In lecture number 27, we will discuss aggregate, cement, bitumen tests and types of pavements. So, first of all, we go for the references. These are the references that I have taken for this lecture. These are the contents: aggregate test, cement test, bitumen test and type of pavements. There are 4 types of tests have been carried out for the construction of the highways. These are the pre-tests, in which subgrade test means soil test, aggregate tests, cement test, bitumen tests. We have already covered subgrade test means soil test. So, now we are going to discuss the aggregate tests. There are various types of tests are required for the aggregate which are used for the construction of the highways, like strength, toughness, hardness, durability, shape, gradation, water absorption, specific gravity, bitumen affection. So, these are the property required to test before starting the work. So, here is the chart in which what are the properties required, name of the test, property to be determined and relevant IS code by which we conduct the experiment. So, we will discuss one by one. The first is strength, and strength is carried out by the crushing test, and the value we get is aggregate crushing value, and the relevant IS code is 2386 part 4. So, we will discuss one by one. This is the equipments of crushing test. Here is the base plate. This is the cylinder for the placing of the aggregate. The diameter of this cylinder is 15.2 centimeter. This is the piston and the dia is 15 centimeter. This is the plunger upon which load is applied. So, this is the cylinder mold, this is the that we have already discussed. The sample we placed in the mold is 10 centimeter. This is the aggregate means sample. So, the sample that we have taken for the test, that should pass through 12.5 mm sieve and retain on 10 mm sieve. First of all, we place these sample in 3 layers and that have been compacted by a tampering rods by 25 blows. And that have been done in 3 layers. So, after placing or compacting the aggregate, then the load is applied through the plunger and 40 tons load is applied with the rate of 4 ton per minute. Load is applied up to 40 ton. After application of the load, then the sample is withdrawn from the cylinder and then it is passed through 2.36 sieve. The passed material is weighted and the crushing value could be obtained easily by the weight of the sample passed through 2.36 sieve divided by total sample multiplied by 100. So, for the bituminous work that should not more than 45% and for granular base and sub base that should not more than 30%. So, this is our crushing test. Now, next is impact test. Impact test is very important for the road construction because vehicle will impact on the road surface when there is a potholes or there is a speed breaker. So, impact load is coming on the pavement surface and that should be evaluated before start of the work. So, this is the cylindrical cup of 10.2 centimeter inner dia and this is the hammer of weight 13.5 to 14.0. The height of the hammer is 38 plus minus 0.5. The sample is again passed through 12.5 sieve and retained on 10 sieve. The sample is again compacted in 3 layers of 25 blows. Now, the hammer is released through the vertical guide bars for 15 times and again sample is withdrawn from the cup and then it is passed through 2.36 sieve. Again the impact value shall be the weight of passed material through sieve 2.36 divided by total weight of the sample multiplied by 100. And for the impact value for bituminous work that should not be more than 35% and for the other type of work means granular work that should not exceed 45%. So, this is the impact test. Now, the third one is a loss angle abrasion test. There are two types of this shearing action is going on the pavement surface. First is called abrasion and second is attrition. When two materials like wheels and the pavement surface produce abrasion, whereas the mutual rubbing between the aggregates is a attrition. So, this could be tested because this is very important because this type of action is going all the time on the pavement surface. So, this should be tested by three methods. One is the loss angle abrasion test, then the dowel abrasion test and Doddy abrasion test. We will discuss loss angle abrasion test. Here there is a cylindrical steel cylinder having 70 centimeter dia, width is 50 centimeter. This is the self and this is the axis of rotation. These are the charger. These are the chargers and generally 12 chargers have been put in the cylinder to create a simulation with the actual site. The diameter of this charger, this is a steel ball 4.8 centimeter and weight is 390 to 445 grams. Generally 12 balls are or chargers are kept in this cylinder. So, this is the cover plate by which we can load or unload the sample. This is the axis of rotations. So, 5 to 10 kg samples are kept in the cylinder, and then this is rotated at the rate of 30 to 33 rpm, and 500 to 1000 revolutions are made for our tests depending on the conditions imposed. So, now after approved number of rotations, then the abraded sample is now withdrawn from the cylinder, and then again it is passed through 1.7 mm sieve. The abrasion value is weight of abraded sample after passing through 1.7 mm sieve divided by total sample multiplied by 100, that will give the Los Angeles abrasion value, and that for base course that should not exceed 50%, and for the high quality of work that should not exceed 30%. This is the flackness test, means safe test, in which there are two tests carried out. One is flackness test and another is elongation test. Both are harmful for the highway construction. If it is if a stone is a flack, then that could not withstand the load coming on the vehicles. So, the flackness index is percentage by weight of the aggregate whose least dimension is 5 by 3 by 5 or 0.6 of the mean dimension of the aggregate. So, this is the slot of 3 by 5, okay, 3 by 5 of the mean dimension through which the stone aggregate is passed, and the value is calculated by the number of weight of the sample passed through the aggregate and divided by the total sample multiplied by 100. So, by this method we can calculate the flackness index. This is the elongation test. It is the percent by weight of the sample whose least dimension is 1 by 1.8 times of the mean dimension. So, by this method we can calculate the flackness index and elongation index, and the maximum limit means that should not exceed 15%. So, the next is sieve test. This is a very important test because it is always done at the site also. So, this is the standard sieve as per IS from 80 to 0.15 size, and this is the sieve having a slot of different size. These are arranged in a descending order. For the purpose of testing of aggregate, the range which are required, one extra top sieve and one extra bottom sieve is also placed for the sieve analysis. So, after putting the sample in the sieve, then it is placed over the shakers, and the sample is properly sacked, and then it is withdrawn and tested again, and by means of percentage passing divided by total sample will give the percentage of the material passed through a particular sieve. So, this is the sieve analysis. Then now come to the next test, which is a cement is a very important test, and because it is used for the construction of a rigid pavement, is the main raw material is a cement, and for even in a flexible pavement also some materials some structures are constructed by the cement like bridge, culvert, etc., etc. So, we will discuss here, and these are the different tests, and the relevant IS code is also given here. We will discuss main tests which are carried out. So, this is the fineness test. This is the fineness test which has been carried out. This is cement and these are the sieves. So, 100 gram sample is allowed to pass through 90 micron sieves, and then it is set for 15 minutes, and then the percentage of passing is calculated. So, the residue should not exceed 10% for OPC or any Portland cement, 5% for RHC and 5% for PPC. So, this test is a sample test, but it is must to carried out before starting the work. The second is a setting time. Setting time is also very important, and you see here this is the Vickett apparatus by which we test the setting time. This is the plunger, glass plates, molds, a stopwatch, and what happened for the setting time? The solidification, initial setting time, the solidification of the plastic cement paste to stiffen to such an extent the Vickett apparatus needle will allow to penetrate the sample up to 5 plus minus 0.5 mm. That is the initial setting time. This is the mold. Mold diameter is 5 centimeter and the thickness is 4 centimeter, in which cement paste is placed. So, and for final setting time, if the needle is released to penetrate the sample, that will not mark that time is a final setting time. It means at the final setting times we cannot change the shape of the structure made by the cement. So, this is the setting time, initial setting time, final setting time. Then the soundness test, it is a very important test, because if your cement is not sound, then there will be wide change in the volume, which creates a great problem for the structure. So, this is the split cylinder, 30 centimeter dia and height is 30 mm. Dia is 30 mm and height is also 30 mm. This is the indicator arms of length 165 mm, length of expansion. This is the glass plate, top view of the Lee Chatelier molds, because this is carried out by the Lee Chatelier principle. So, this test is carried out by the Lee Chatelier molds. So, what happened? The mold is placed over the glass and filled with the cement paste, 100 gram cement and 0.78 times of water, then the cover with a glass sheet, submerge in water at 27 to 32 degree for 24 hours. Now, mold is taken out and again submerge in boiling water for the 3 hours, cool down, and distance between the indicator point is measured. So, the difference between the indicator will show the soundness of the cement. So, this is the soundness test, and it is very important test, because if there is a unslacked lime, a slacked lime, then it will create problem when water will come in contact with the cement, residue cement. So, the next is a strength. So, the specimen 70.6 mm cube having 5000 square mm of surface area, 1:3 cement and water is mixed at 27 plus minus 2 degrees centigrade, and the quantity of cement 185 grams, 555 grams, P by 4 plus 3.5. Here P is the water for the normal consistency. Now, mold is filled with the paste. Now, vibration table is allowed to shake for 2 minutes, and after removing the mold is placed over the compression testing machine. This is the compression testing machine, and the load applied is 35 Newton per square mm per minute. Is it? So, the strength could be find out by the total strength divided by the area, that will be the stress, the strength of the cement. The next is heat of hydration. There are many stages for the heat of hydration. So, the heat of hydration is calculated by the heat capacity, corrected temperature, weight of the sample, ignition loss, and we calculate it with the different stages. Finally, we come to conclusion of heat of hydration, because it is a very long experiment. So, we will conclude it by just showing the sample here. This is the colorimetric apparatus by which we can calculate the heat of hydration. The next is the specific gravity test, and for the specific gravity test, it is found out by the weight of the cement, divided by the displaced volume of liquid in millimeter, that will give the specific gravity. So, this is all. There are again many tests are to be carried out for the cement, but for the practical purposes these tests are only carried out in the field. So, now come to the bitumen test, and there are many bitumen tests which are carried out for the bitumen. One is, first is a needle penetration test, then the softening point test, flash and fire test, viscosity test, ductility test, float test, loss on heat test, solubility test, a spot test, water content test, TFO test and RTFO test. These are the tests which are generally carried out for the bitumen. We will discuss in brief. This is the needle apparatus, means needle penetration test, and the bitumen is named after the penetration test, like penetration grade between 80 by 100, means the needle penetration is lies between 80 and 100. But this type of needle penetration test have been carried out and named after this penetration value. But now all Indian companies like Indian Oil Corporation, HPCL, BPCL, these all companies have now changed, and now the name of bitumen is based on the viscous grade, VG grade bitumen, like VG 20, VG 30, VG 40, like that way. So, now the bitumen has changed, but this is the very basic test. Here you see this is the 100 gram weights, and this is a needle of 1 mm, 1 mm. This is the sample that we have placed, sample is placed in a cup, and this is a dial for the measuring penetration, and this dial is not in millimeter, but 1/10 of the millimeter. So, now the sample is placed below this needle is placed just above the level of the sample, and then this is the press button by which this is the weight is released, and after 5 seconds again it is pressed. So, it will stop at once. So, the dial gauge will represents the penetration value in 1/10 of the millimeter. So, this is the softening point test setup, in which between softening point is calculated. This is flash and fire point. This is the minimum temperature at which the for a very small instant there is a fire, and for the fire point then there is a ignition. This is a viscosity test in which sample is allowed to collect in a 50 cc flask. The time required to fill up to 50 cc, that will give the viscosity. Then the ductility test, in which sample is now allowed to 50 mm, allowed to pull 50 mm per minute, and up to the end point when the thread is break. So, that will give the ductility value. This is the float value. There is a brass and aluminum throat in which sample is kept, and it is kept in the water bath at 50 degree and force water to come up. That time will give the float value. This is the loss of heating, means if you are heating between the volatile material will escape into the air. So, the difference will be the loss of heating test. Solubility test, the bitumen is makes soluble in carbon tetrachloride or carbon disulfide, and the residue will give the solubility value. This is the spot test. The sample 2 gram sample is now dissolved in the naphtha, and drop of this solution is placed over the paper, and after 24 hours, if it is a regular and a regular color, then it is uncracked, and if there is some deformation in the shape and color, then it is uncracked, then it is cracked. The water content, some water content will be there, then it is heated and collected the vapor and again cool down and make a water. So, that will give the water content that should not exceed 0.2%. This is the thin film oven test. This is an important test that has been carried out. So, this is the horizontal rotating shelf on which sample is kept in 140 mm disc up to 5 mm, 10 mm thickness, and it is rotated, and then the loss is calculated. This is the rolling thin film oven. It is rotated in the vertical alignment, and again for the accelerating the rate, then the nearly hot air is passed through this, and then it is wetted again. So now from here, now I am ending this topic. We will discuss the things in the next lecture. So, thank you very much. Thank you.